to the online embryology course. I'm Steve Oppenheimer. I want to thank Paul Wilson, who really was the motivation for us doing this embryology online course. Let me give you a few tips about how to do very well in this course. And that is, you'll have lots of drawings to do. Those are required drawings. Do them neatly, do them beautifully. Why do you have to draw? You'll remember it well that way, and then when you ask for a letter of recommendation, and if you have a beautifully precise drawings and beautiful precise report, then if you're applying, let's say, to dental school, I'll say, you know, this student does beautifully, meticulously, careful work, very precise, which is critical for success in dentistry, and the same for all of these other areas. So doing beautiful work in this laboratory is going to help you immensely. Why do you even need to know this kind of material? And that's because this is fundamental to biology. The development of embryos is fundamental. And although the patterns may be different, the end result is the same. And we'll see some beautiful patterns of how embryos develop. And you'll see they'll all go to the final, same, beautiful adult organism. Let's move on to figure number 7, the frog testes. We go to the microscope. We could see figure number 7 here, a slide that is similar to figure number 7. And what you'll see in the frog testes is that the early developing sperm cells, the spermatogonia, are on the periphery of the testes. Then as they mature, you get spermatocytes, and as they mature, they move towards the center part, the lumen. And the mature sperm then are at the lumen, and then they could be ejaculated out and fertilize the eggs. That's sex. Now when we move to another phase of embryology, probably a lot of people consider the most important phase of all, and that is gastrulation. A famous embryologist once said, "It is not birth, marriage, or death, but gastrulation that's truly the most important time in your life," because that's the stage where the layers of cells go from the outside to the inside. It's no longer just a ball, but now it becomes a layered embryo, which begins to really resemble the adult. Now, if we look at figure 11, what you'll see is a frog blastula. That's the hollow ball stage. And now we get to the gastrulation stage. And you'll see cells start moving in dorsally. This is the dorsal lip of the blastopore. This is the blastopore. So cells are moving from the outside to the inside of the embryo. Now, if we look at a view from the outside, the surface, you'll see the little slit. That's dorsal. That's the dorsal lip here. But the cells are moving into that blastopore. But now they're going to start moving into the blastopore also laterally. So this blastopore is becoming sort of a half moon shape. Finally, cells are moving in to form the blastopore ventrally. So now we have a circular blastopore that's shown in figure 12, but it's only a slice through it. So you don't see the lateral in figure 12. So what we have now is what's called the late gastrula, or the dorsal, or the yolk plug stage. You see, these are cells in here. These are cells. And what we had is that the cells moved in dorsally, moved in laterally, moved in ventrally. So we basically have what's shown in figure 12. When you cut it through, you see dorsal, you see ventral, you don't see lateral, but you see this yolky plug of cells, which we call the yolk plug. So now cells have moved in dorsally, laterally, and ventrally. We got cells moving from the outside to the inside, as shown in figure 11 and 12.